box plot is a graph of the 5-number summary. Okay, and we will use these quite a bit. Click daily charges. And I think that's all we want right now. Oh, you know what, where it says markers? Let's mark the mean and the median. Just for kicks. Compute. Oh, you know what? Okay, let's go back. Options. Where it says draw boxes horizontally, click in front of that. You can draw box plots vertically or horizontally, but for me, vertically is really hard to read unless you have a whole bunch of them and you're comparing them. So I kind of prefer horizontally. So are you with me? Box plot, select your data, draw boxes horizontally, and I'm gonna mark the mean and median so we can see where those show up. Okay, there we go. So notice a box plot. You know, you guys just stay where you're at for a second. A box plot is such that you have the box in the center. The box itself marks the quartiles. So the left-hand edge of the box is Q1. The line, wherever it appears in the box, is the median, or Q2. The upper, the right-hand edge of the box is Q3, and the whiskers are the min and max. So here's the smallest credit card charge in this data. And I think if you hover over it, it tells you the values. Am I right there? Oh yeah, there we go.
And if you click, like it'll like highlight which one it is.
Say again?
Like if you click like over by like the min, it'll highlight where that is on like the table too. So
Oh, like
it'll
that?
show you, yeah, where stuff is.
Oh, Julio. You guys teach me stuff all the time. Hey, just click on that, click on the median, or or Q2. How about here? Is it highlighting the stuff smaller than, I guess, huh? Oh, cool. So we clicked on all the values that are from Q1 to Q3, it looks like. Well, that's kind of neat. All right. A box plot, so it's telling us that, get those values. The min is 20, Q1 is 84, the median, which is Q2, is 106, Q3 is 138, and the max is 212. So what it's saying is 25% of these credit card charges are between $20 and $84. You with me? 25% are between $84 and $106. 25% are between 106 and 138, and 25% between 138 and 212. Okay? So again, it's ordered data, and it chops it up into like four like regions or areas, smallest to largest. Another thing we like about box plots is that they can show us the distribution. So remember, this is the middle 50% of the data. So it's stacked up pretty much in the middle, and here are your tails. And they're pretty even, so this data would be symmetric. You with me? Does that make sense? Middle 50%, right? 25% on each end, kind of pretty much even. You with me?
Exactly what all of them are. They're always kind of stacked in the middle like that.
No, they can be all different wacky shapes. Okay, so yeah. Well, and we'll look at another example or two. there's also another measure that you may be asked about. It's called the interquartile range, or the IQR. And what it tells you is the number of units between Q1 and Q3. So the interquartile range, or the IQR, again, it's just the span of the number of units that that middle half of the data takes up. Remember that the range is just the difference between the largest and the smallest value, so it gives you the number of units that the entire data set takes up, where the interquartile range is just the middle half. So you find it by taking Q3 and subtracting Q1. And again, it's often given as IQR. Okay, so going back to, you guys also clicked on those markers. Note that also the mean and median are really close, which would indicate a symmetric distribution. Okay, yeah, so box plots. Let's grab some more data. Let's try number 27. This data is a random sample of college students. A survey of 50 randomly selected full-time Joliet Junior College students. That's where the author of the book teaches. It's by Chicago. This is during the fall 2010 semester. They were asked to disclose their weekly income from employment. So if they didn't work, $0. Okay, so let's check out a box plot of that data. And excuse me, I'm going to draw the box horizontally. Now check it out. If you look really closely, here's the min. It's a little black stripe over here. There's your Q1 to Q3. So really, 75% of your data is within this range. 25% is here. So we can go back and something wacky's going on. Something really strange is going on. If you hover over the max, you see that the max is $12,777. So some kid is making over 12 grand a week. What's that kid selling? Right? What do you think would explain this? Because remember, somebody has to, once the data's gathered, somebody has to type it in the database. Do you think perhaps they got a little heavy on the sevens there? Maybe $127 a week would sound normal, right? Go back to your data. Let's close out of there. There's that value of 12,777. Let's click on that and remove a couple sevens. That seems more in line with the rest of the data. Okay, and then let's go back and graph a box plot again. And again, I'm going to draw the boxes horizontally. That seems more reasonable. That seems more reasonable. So if you want to, find your 5-number summary from the box plot, you're welcome to do that, because obviously it shows what they are. Your min is 0. And generally, the 5-number summary would be written in order, from min, Q1, Q2, Q3, max. Q1 is 67. Q2, also called the median, right, is 271.5. Q3, let's see, 476. And the max, or the largest value, what do we have there? 736. Okay, so there's your 5-number summary, and remember, if you just want the quartiles, it's Q1, Q2, Q3. Okie dokie. So 25%, if you were, okay, so if you were using this data to make an inference about the income of all Joliet Junior College students, you might say 25% of students make between 0 and $67 in a week. 25% make between 67 and 271.5 in a week. 25% make between 271 and 50 cents and 476 in a week, and 25% make between 476 and 736 in a week. That make sense? How many Joliet Junior College students make between 67 and 736 in a week? How much? 75%. How many make between 0 and 271.5 in a week? 50%. Yeah, right. Right. So it's another way of, looking at, position within a distribution. Is your income in the first quartile? Is it in the second quartile? Whatever. Okay, let's, oh, and notice, the first quartile is kind of narrow. I think this thing might have a slight right skew. When you've got a whisker that is really long, it's saying that, if you've got only 25% of the data within that really large area, it would indicate a skew in that direction. This, I'm not so sure. I don't know if there's enough there to have a bit of a right skew. What we could do to figure that out is to mark the mean and the median. If it has a right skew, which value is going to be considerably larger, the mean or the median? If this data has a right skew, which value would be larger, the mean or the median? Which one is not resistant to extreme values? Sorry? The mean, right? Remember, because it considers all the data, the median does not. So if this data has a right skew, the mean is going to be considerably larger than the median. Looks about symmetric. So mean and median are in the same spot. Does that make sense? Make sense to everybody? Okay. Another way you can find the 5-number summary, if you don't want to use a box plot, is under our summary stats, where we found the mean, standard deviation, median, mode, all that happy stuff. So if you just click your data and calculate, you can see there at the end, you've got min, max, Q1, median, and Q3. So your 5-number summary is all in that output as well. And then you can see here that the mean, 276 compared to the median, they're pretty close. Especially across a range of 736 units. Okay, are you guys with me? Is this okay? Doing okay? Good, okay. Let's play with some more data. Here's an example of how the boxes might look if you had a skewed distribution. This is in 3.5, I'm not sure what page for you guys. But you can see that when the min to Q3, so you've got 75% of your data within this range, and only 25% in about the same range. Does that make sense? Does that make sense? So distance, say? The distance from Q1 to Q3 is about the same distance as from Q3 out to the max. So again, you've got 75% of the data in this range, which is gonna make it pile up on this side, right? You with me? And then it's gonna taper off to the right, which is gonna give you a right skew. Okay? The data that we've seen, and again, it doesn't have to be perfect, you know, perfectly aligned, but it's kind of a relative thing. When the box is about centered with about the same length of whiskers, you're gonna have a symmetric distribution, and then a left skew if that left whisker is considerably longer. Okie dokie? Cool. Let's do this. Problem 3, 5, 16. 3, 5, 16. There's going to be 2 data sets there. This data is the number of chips, oh, hang on, per cookie. So Keebler chocolate chip cookies, and then the store brand like, I don't know, Safeway or Rayleigh's or whatever. And how many chips per cookie in a random sample of 21 cookies. So would you find the 5-number summary of each of those little data sets? And then let's look at box plots together of the cookies. So if you go to box plots and you just drag both of the data sets, they'll come out on one graph and you can compare them. That's another nice thing about box plots is, so it's kind of easy to see the shape of the distribution. Although with small data sets, they don't work that great. But small data sets are a little difficult anyway. But they give you shape of distribution and oh, and they're nice and comparable. They're very easily comparable.